All right, for this third problem, it's going to bring it all together, and we're going to need to think about the ratios of area, volume, just the linear scale factor, the linear ratio, but then also apply it to a new situation. So let's read this problem and see what we think. Prism A and prism B are similar. The volume of prism A is 8 cubic units, while the volume of prism B is 729 cubic units. If the surface area of prism B is 65 square units, what is the surface area of prism A? All right, so there's a lot going on in there. So I think the most important thing when I approach a math problem is to look at a few things. One, what are they asking for from us? So in this problem, the final goal is to find the surface area of prism A. And then you want to ask, what do we already know? So we know we have two prisms, A and B, and I've drawn those here. We also know they're similar. Again, same shape, not the same size. And we know the volume of both A and B. And I've labeled this A and B. It's not the top side. That is labeling the entire figure. But they say that the volume of prism A is 8 cubic units. So I'm going to write V equals 8 units cubed. And then for B, we have V equals 729 units cubed. So obviously this picture is not to scale. This prism is not that much bigger than the first prism, but it's just the idea of it that it is a bigger prism and we need to study. The final thing we know is the surface area of prism B is 65 square units. So I'm going to write down here SA equals 65 units squared. But there's a lot of several steps that we need to take here to reach our final answer. So the first thing we want to do is we want to find that volume ratio, the ratio of the volumes between our similar shapes. So here they give us the actual volumes. So we need to say, is that actually the ratio of the volumes, or is that just the two volumes? Well, we need to simplify the fraction to know for sure. And you'll find if you do take 8 over 729, that is simplified. So that would be our volume ratio. We would get 8 over 729. So now we want to find the linear ratio. So again, we're transforming or translating between these different dimensions or different levels. So if we know the ratio for the volumes, and we want the ratio for the linear scale factor, or just the ratio of similarity, you may hear it called sometimes, well, that's where that cubed comes into play. So if we had the linear ratio and we wanted the volume ratio, we would take our linear ratio and cube it. So to get from the volume ratio back to the linear ratio, we need to do the opposite operation, which is the cube root. So for a cube root of a fraction, you can take the cube root of both the numerator and the denominator on their own. So what is a cube root of 8? Well, it's 2, because 2 cubed is 8. And what is a cube root of 729? You may need to plug in your calculator. If you do, you would get 9. So our linear ratio is 2 over 9. Do we want to know the linear ratio? Well, not for our end problem, but the thing is, that is where we needed to go to get there. Because we want to get to the surface, or the surface area ratio, which is the area ratio, that second level in some sense. But it's not as easy to see how you get from volume to area. So we're going volume to linear and then back to surface area. So now that we have the linear ratio, we can get directly to that area ratio by squaring it. Because to get from linear ratio to area ratio, we take each component and square it, just as we saw in the first problem in those tables. So 2 squared is 4, and 9 squared is 81. But now we're not done. We've got into the important part of the problem, that area ratio, because now we can apply that to the final problem, but we need to use that information now to get to our answer. So we have the area ratio, and then we also know that prism B is 65 square units. So what we need to do here is we need to actually set up a proportion. So we're going to take our area ratio, A over B, and we're going to set it equal to our desired ratio. So we had 4 over 81 as our area ratio. Sorry, it's a little sloppy. I'm writing with a computer keyboard here. So we'll write 4 over 81 is going to equal, and now we want to actually put that surface area because we have the area ratio, and now we have some component of area. So we had the surface area of, was it A or B? In this case, it was B. And in the ratio, 81 applies to prism B. So we're going to write 65 down in the bottom. And what we don't know is we don't know the surface area of prism A. So I'm going to write X up here. And I bet you know how to solve this. When you have a proportion set up in this manner, what we're going to do is we're going to cross multiply. So we're going to multiply X and 81 and set it equal to 4 times 65. I'm going to move it over here so we have room. So we're going to get 81X equals 4 times 65. So this is how we set up our proportion. Once we have that ratio and we have an unknown quantity, we're going to take this, cross multiply, and get this. But now we just have an equation, and all we need to do is solve. So first, we want to multiply the right side of that equation. 4 times 65 gets us 260. And now we have 81X equals 260. The final step is we need to divide 260 by 81. So we're going to get X equals 260 divided by 81 is 3.20987, yada, yada. And it asks us to round to 2 decimal places. So we're going to get X equals 3.21. And we can plug that in right here. The last thing I encourage you to do is to use your skills of estimation a little bit to check your answers. Basically saying to yourself, doesn't make sense. Well, the volume of prism A is much less than the volume of prism B. So we'd expect the volume of, or the surface area of prism A to be considerably smaller than prism A, surface area of prism B. And here it is. Prism B is 65 and prism A is 3.21. So that checks out with what we would expect for the problem. So that's just a way to check your answer that you've got. So knowing that it makes sense and also you did the math, that is our final answer.